Lesson 3.7, composition of functions. This is video number 2. We're on example 4. So let f and g be real functions defined by f at m is the square root of m, and g at m is 2 divided by m minus 3. Find the domain of g composed with f. So we're going to put the f function into the g. We're going to put the square root of m right here. Okay, so I want to find the domain of the function defined by 2 divided by the square root of m minus 3. Many times the domain can be all reals. However, first of all, because I have a square root, I realize, especially because they're real numbers, we're not dealing with imaginary numbers, real numbers, whatever is underneath of the square root has to be positive or 0. So to start out, I know that m has got to be greater than or equal to 0. I cannot have a negative under here. Then I have another stipulation on my domain, because the denominator of a fraction can never be 0. So the only things that are going to give restrictions on domains are square roots and fractions. So if you have a variable in the denominator, you need to make sure your denominator, that my square root of m minus 3 has got to be greater than 0. Not greater than 0. It can't equal 0. I was looking up here at this, I'm sorry. So you can have positives in the denominator, you can have negatives in the denominator, which is why I didn't say that it had to be greater than. It just can't equal 0. If you take 2 divided by 0, you will get an error on your calculator. So the square root of m minus 3 cannot equal 0. So I solve this equation. I add 3 to both sides, and the square root of m cannot equal 3. I then square both sides to get rid of that square root. M cannot equal 9. Therefore, the domain is that m is greater than or equal to 0, except m cannot equal 9, because 9 is greater than or equal to 0. That is my domain. Now, for example 5, rather than defining with an equation my functions, I've given you a table. And so we're going to use these tables to answer A, B, C, and D. Letter A says find g at 0 first, because you always work from the inside out. So g at 0, let's see, when x is 0, we get 4. And then put 4 into the f function. When I put 4 into the f function, I get 5. All right, so let's review that. G at 0 equals 4, and then f at 4 equals 5. And that's how I got that answer. Let's go to part B, f at 3 first. So f at 3, the f function at 3, when I put a 3 in for x, I get 0. And then I'm going to do g at 0, I get 4. The next one, I'm going to put 1 into the g function, g at 1, I get 1. And then I'm going to put that answer into the f function, and I get negative 1. Okay. F at 4, I put 4 in, I get 5, and then I'm going to put 5 into the f function, and I get 5. Okay, so I'm going to see if I can get through at least one of the lesson masters in these next 10 minutes, and then you, hopefully, that will be enough practice to help you do the other lesson master on your own. All right, so we're going to start off by putting 1 into the g function. When I do that, I have 5 times 1 minus 3, which gives me 2. And then I'm going to put that 2 into the f function. So f at 2 is 2 squared plus 2 times 2 plus 7. So that's 4 plus 4 is 8 plus 7 equals 15. For part B, I'm going to put 1 into the f function. So f at 1 is 1 squared plus 2 times 1 plus 7. So that's 1 plus 2 is 3 plus 7 is 10. So then I'm going to do g at 10, which is 5 times 10 minus 3. 50 minus 3 is 47. Okay. Now, for number 2, I'm not going to substitute a number in, I'm just going to find a formula. So I'm going to put the g function into the f function. So I'm going to take this 5x minus 3 and put it in for x here as well as here. So I get 5x minus 3 squared plus 2 times 5x minus 3 plus 7. Alright, I gotta square this 5x minus 3, so I've got to FOIL it. And then this, I'm going to distribute the 2, so I get 10x minus 6, and I still have the plus 7. Now, for 5x minus 3 times 5x minus 3, I'm going to use FOIL. My first terms, I get 25x squared. Then my outer terms are negative 15x, and my inner terms are negative 15x, which gives me negative 30x. And my last term, negative 3 times negative 3 is positive 9 plus 10x. And I have negative 6 plus 7 is plus 1. So I need to get my like terms together. 25x squared minus 30x. Oh, not minus 30x, it's actually minus 20x, because I have negative 30 and positive 10. And then I have 9 and 1, which gives me 10. So my final answer is 25x squared minus 20x plus 10. Then for part B, I'm going to put my g function into my g function. So I'm going to put 5x minus 3 in for x. So right there, I'm going to have to put a 5x minus 3. So 5 times 5x minus 3 minus 3, which gives me 25x minus 15 minus 3, or simply 25x minus 18. Right, now for this next one, we're going to put the g function into the f function, which means I start at g and then I move to f. So in g, I begin at 7 and it takes me to 6. So now look for 6 in the f function. There is not a 6. There's only a 1, 2, 3, and 4. So for the first term, we can't use that one. Can't do anything with it. Let's go to the next term. I begin at 1 and I get a 3. So then I come up to the f function and I look for 3. And it's right there. 3 leads me to 2. So I began at 1 and I ended at 2. So for that first one, I began at 7, went to 6, and 6 didn't go anywhere. So for that one, it was undefined. All right, now I'm going to begin at 2. That takes me to 2. I go to 2, that takes me to 4. Next, I begin at 4, right here. 4 takes me to 1. Where does 1 take me? To 7. And that's F composed with G. Now we're going to do G composed with F, where I'm going to start with the F function. So I start at 1, which takes me to 7. 7 takes me to 6. Then I start at 2. 2 takes me to 4. Where does 4 take me? To 1. Then I begin at 3. 3 takes me to 2. Where does 2 take me? To 2. Begin at 4. 4 takes me to 1. 1 takes me to 3. So I'm always starting with the X value and ending with a Y value. Same kind of thing here in number 4. We're going to look at a visual mapping. Start with the J function. Where does the J function map A? This is my J function right here. And it takes A and it maps it to B. And then put B into the H function. If I put B into the H function, I just get B. Let's start here with B. Start at H at B. The H function, where does B map? B maps to B, then take it in the J function, it maps to C. With this notation, still you start with J. The J function takes D and maps it to D. Put D into the H function and you get C. Right, for the next one, give the domain for each composite. Put S into N. So we are going to take S and put it into N. Okay, so I'm going to take the square root of x minus 1 and I'm going to square it and subtract 2. Now, even though when we square a square root it goes away, because this square root is here to begin with, we have to make sure that whatever's under this square root is positive. So x minus 1 must be greater than or equal to 0. Add 1 to both sides. X must be greater than or equal to 1. That is my domain. Now put n into the s function. So I'm going to take x squared minus 2 now. I'm going to take this right here and put it under there. So I have the square root of x squared minus 2 minus 1, which simplifies to the square root of x squared minus 3. Well, because it's under a square root, we say that x squared minus 3 must be greater than or equal to 0. And so we add 3 to both sides. X squared is greater than or equal to 3. And then we take the square root of both sides. And we get that x is greater than or equal to the positive square root of 3, or x is less than or equal to the negative square root of 3. Because remember, when you were in Algebra 1 and you multiply or divide by a negative, you have to flip the inequality sign.